Hi, welcome to How to Repair. Today we're going to be fault finding and diagnosing problems on modern electric cookers that are controlled with circuit boards. And we're going to be using a smart meter so we understand what is going on and how to diagnose the problems. This is a Hotpoint machine manufactured by Whirlpool, and we also have a couple of machines underneath, a Bosch to the left, and I think this is a Beko branded machine here on the bottom right. The actual main components of the cooker are exactly the same. Let me explain. We have a base element, we have a grill element, a fan oven element, a fan motor to distribute the air in the oven, and we also have a cooling fan to keep the electronics cool. Exactly the same on all three. The thermostats that are used in the old conventional ovens were £20–30 to replace. The Selector switches were roughly the same price. The timers could be up to £50 to £100 depending on the manufacturer of the timer. But the actual ovens that have the circuit boards in are ridiculously expensive and have built-in obsolescence designed into them by the manufacturer. The display board for this machine is £130 as of today's prices. The main circuit board for this machine is £150. If any of these components fail, I do not blame you going out and buying a new machine, but in this video I'm going to show you how to diagnose problems and also point you in the right direction to repairing the circuit board where it can be something simple like a relay or a blown track on the circuit board. Okay, let me explain the setup I've got here. This cooker is out of situ, meaning it's not in the housing anymore. I've taken it out to work on because we have a fault and it's not heating on the main oven. We've got it connected to a smart meter. This basically reads the wattage or the ampage of what's going on inside the cooker to let me understand what is working and what's not working. And you'll see this in a second. You need to understand what power should be seen via each component on the cooker. The light bulb on this is 40 watts. The base element on this cooker is approximately 1300 watts. The grill element is 2600 watts, the fan oven element is 2000 watts, and the fan motor for distributing the air inside the oven is about 20 watts, and the cooling fan is about 20 watts. You need to understand these values so you know what you're looking at on the actual display here. Right, on the circuit board we have multiple relays. On this circuit board we have 8 relays, 2 high ampage relays and 6 lower ampage relays. And these will turn on the functionality of certain components like fan motors, base element, light fitting, also other cooling fans and so on throughout the cooker. Now this was all done in the old days by a selector switch, which would be turning the selector switch to a set pattern, and that would be sending power to a certain element and a certain light or a certain fan motor. This then controls the temperature with a thermostat. The thermostat is basically a capillary tube connected to a probe which is filled with gas, and as it got hot this gas would expand, therefore shutting the points at a preset value inside the actual thermostat. So for example, the fan oven setting on this is down the bottom. So you'd select the fan oven setting, you would then turn the thermostat to 100 degrees and the little light would come on automatically here, and you would hear the fan running and the element should be running. If the thermostat light goes out, this means that the cooker had reached temperature and therefore shut power down to the element. If it was not heating and not drawing power on the element, that light would stay lit but the oven would be cold, indicating that we could have a problem with the fan oven element. With the circuit board types it's a lot more confusing because we have NTC sensors, if they're not working correctly, are not sending the correct readings to the circuit board, therefore the relays will not open and send power to the element. A relay could become faulty, not sending power to the element, or we might just have an element that has gone faulty. So we need to understand what is going on. Okay, using our smart meter now, we're going to actually understand the wattages that are being drawn as I go through some tests on this oven. I'm going to test the fan oven setting, which is not working correctly. I'm going to show you the grill working so you can actually see that it's drawing power and the relays clicking in and out to control the power. And I'm also going to use the conventional oven setting with the fan to actually use the base element, the grill element, the fan motor and other sensors sensors inside the machine, and you need to listen closely for the actual relays clicking in and clicking out. I've actually put a microphone on top of the actual cooker here to try and enhance the sound off the relays so you can actually hear them. Now, the first thing you'll notice is we've got 0 power showing on the meter here. I'm going to open the door and the light will come on immediately because of a switch inside the door. And I'm going to use this as an example of a low ampage relay. You heard the relay click and the light came on straight away, and there is a switch in the top right hand corner. Now, the circuit board actually has a time delay when the light goes off. So if I press this button, if it was wired conventionally, it would turn the light off immediately. But because it runs through the circuit board, it will actually turn a relay off to stop power going through to the light. And it's normally about 7-8 seconds. So I'm going to press this button now, and the light's still on. You heard the click, and that was an actual relay turning off the power for the light. But when I let the switch out, the computer program knows to turn the light on immediately when this switch is let out. Because the bulb is 40 watts, you will actually see it drawing 40 watts of power. There's also a couple of watts extra on top of this because it's using relays on the circuit board and they consume power as well. So let's test the fan oven element setting. Now, this will be drawing 20 watts of power for the actual fan motor. We then will have the light on, which will be 40 watts of power, and we should have the fan oven element coming on, which is 2000 watts. So we should be seeing somewhere in the region of 2060 watts of power being drawn if it was working correctly. So I'm going to set this to the on position, turn it to the fan oven setting. It's set at 180 degrees, which I have to agree that that's the temperature I require. It'll then ask me for how long I wish to cook. I just want it on manual. You will hear the relays. We heard 2 relays clicking there, and we've only got 68 watts of power being drawn. But if I open the door to show you, you can see the fan motor is running and the light is on. But we've only got 68 watts of power. This actually means that the fan oven element isn't drawing any power, or no power is being sent to the fan oven element. So we have a possible 3 faults that could be taking place. The NTC sensor is not working correctly, therefore sending the incorrect ohms reading to the circuit board, and therefore the relay decides not to send power to the element. Or we have a faulty relay on the circuit board, meaning that the relay is not sending power to the actual element, or we have a faulty element. Now, the only way we can test this is with a multimeter once we take the rest of the chassis off the cooker to expect the actual voltage going to the element, and also do a test on the element, which we'll do in a minute. But I quickly, while I've got it set up here, want to show you the grill function working and show you how the relays are working for the grill. And we'll also use the conventional oven setting, which uses a combination of the base element and the grill element to maintain the temperature with the fan motor. So I'm going to turn it off, turn it back on again. I'm going to set this to grill only with no fan motor, and we've got it set up on number 3. I'm going to press on, time, we want it on manual, and what I want you to listen for is the relays. And also look here. 1 relay clicked, and now we can see 2800 watts of power being drawn. This means that the grill element is working correctly and it's started to heat. The light is on, so we're drawing 40 watts of power. So roughly we've got 2700 watts of power being drawn by the grill element with no fan motors running. The only time a fan motor will come on is when the oven gets hot. It will turn the cooling fan assembly on. Now I'm going to stop this now and turn it to a more complicated program, which is using the grill element and the base element and the fan motor. Basically, it will alternate between the base element and the grill element using the NTC sensor, which is sending the ohms reading to the oven. And as we adjust the temperature on the oven, you will see different wattages actually come up on here, and you'll hear different relays clicking in and out. And we should hear at least a couple of relays clicking in when we turn this on. Setting it onto the actual twin settings, 180 degrees. Now listen closely for the relays and also listen for the fan motor coming on. Two relays clicked then. We've got 2,850 watts of power being drawn. Now, if I'm lucky, I'm able to set the temperature now, drop this temperature down to about 115 degrees, and we should see the computer now disconnecting the grill and turning the base element on. 2 clicks. One was the grill going off, the other was the actual base element coming on. If I increase the temperature now, we might hear it actually increase the temperature by turning the grill on because it's got a higher wattage, and it will turn the base element off and turn the grill on, and the fan is the one that's distributing the air within the oven. Two clicks. We're now drawing 2,800 watts of power. So we know the relays are working correctly for the base element and the grill element. The fan motor is running, and this is what's distributing the air around in the oven. And the NTC sensor is actually taking an ohms reading and sending the information to the computer board and rotating between the main element at the top and the base element at the bottom. And I heard it click again, and now it's actually gone on to the base element. Okay, I've disconnected the cooker from this power supply, and first thing we're going to do is take the top off. Now we need to take this back panel off. You can see the main circuit board here. Okay, as we've got the cooker apart and not connected to the electricity, I'm going to actually show you how to test all the elements, the temperature limiter, and also showing you the value at room temperature of the NTC sensor. Now, the problem being is with things like NTC sensors, the manufacturers should give you a graph showing you what the NTC sensor should be at room temperature, 20 degrees, showing you what it should be reading at 100 degrees, 200 degrees. The manufacturers keep this information to their own engineers and do not disclose it to general public. But as long as you're getting a reading of somewhere around 1080 at room temperature, you know the NTC sensor is operating correctly. And of course, as you warm the NTC sensor up, that number will increase. So first, let's actually put the multimeter on top and test the elements. Now, you could do a continuity test on each element. We know the grill is good, we know the base is, we don't know about the fan oven element at the moment. So I'm setting the meter onto 200k range on ohms, and I'm just going to test, and take one wire off each of the elements. The base element is the lower wattage, so that will be a higher ohms reading. And we have 44.1 ohms reading on that. The grill element is the biggest wattage, so that will be the lowest ohms reading, and we've got 20.8. And the fan oven element is open circuit. That's our problem with our oven not heating. But I'm also going to show you how to check the relay power going to the element as well in a minute. So let me connect these back up, and next we'll have a quick look at the temperature limiter, which I just checked just now, and the temperature limiter cuts out at 285, meaning it should go open circuit if it ever exceeded 285 degrees. For that, all we need to do is set it to continuity and test across the two terminals, and that means it's good, we have continuity. And the next one we need to test is the NTC sensor, and that goes to the circuit board here. And as I said, the NTC sensor on this machine is part number C00311498. Now, the manufacturers, if they were playing fair with the general public, would actually give out a chart showing the NTC values of these sensors, but they try to keep all the information to themselves, so it's only their engineers that are able to actually work out if there's a problem. But most NTC sensors on ovens would have a value of somewhere in the region of 1080 at room temperature, and that number will increase, of course, as the actual room temperature, the oven heats up. And I've got my meter set onto the wrong setting, and there we go. We have a value of 1095, and I've set the multimeter up onto a 2K range on the ohms. So we know all the components are good on the machine apart from the fan oven element, which I'll replace shortly. But I also wanted to give you a detailed look at the circuit board and explain the problems. But what I do want to show you is basically what the voltage is coming through to the element if the relay on the circuit board is correct. We know the value on the NTC sensor is correct, and that connects to the circuit board at the top here. So I'm quickly going to connect up the cooker, and we'll set it to the fan oven setting and see what the voltage is coming down to this fan oven element. Okay, I've actually connected the cooker back up to the power supply now to show you the other way to test the fan oven element with regards power coming from the relay. We know now that the NTC sensor is within the values, but if you wanted to do a test and you still had no voltage at the element, you could do it this way. So I'm going to place my meter here for you so you can see, because I have to go round to the front of the cooker, and I'm going to use my Crocodile clips on the meter, connecting one to the neutral and the other to the live, and when I go round to the other side we should hear the relay energizing and sending 240 volts to the fan oven element. So I'm quickly just going to turn this on, fan oven setting, and what I want you to also listen for is the relay on the circuit board. As it energizes, you'll see the meter should have 240 volts. There's the relay clicking. Two relays clicked. One for the fan motor, and the other relay was the larger ampage relay on the circuit board, which we'll look at in a minute, which is now sending 240 volts through to the fan oven element. Okay, we've disconnected the power from the cooker, and I'm just going to take this circuit board off for you so you can actually have a close look at it, and I can explain all the relays and the other components on the board. Whenever disconnecting any wires off these circuit boards, do take a photograph of where they come from. They are normally pin coordinated and they can only go in one way, but it's always best to take a photograph. So I'm just going to disconnect these components. So let me explain, sorry. 4 wires going up to the control board at the front. Then we had the NTC sensor, and this 2 wires on PO4 basically are the door switch. Then we have another block down the bottom which is going through to a fan oven element, cooling fan, sorry, and another component down here. Then we have the heavier wires which are normally going through to the actual elements, and we have another terminal block there which is the neutral coming in. This is basically the circuit board. Now these relays are replaceable. This is an Omron and it's a 12 volt DC, 16 amp, 240 volt. And if I can take this circuit board off to show you the other side. Okay, so the plastic catches just hold the actual circuit board in place, and I'm going to take that away so we can have a detailed look at this. Basically resistors, diodes on the circuit board, capacitors for controlling things like the lighting and other bits and pieces. The main functionality of these boards is the relays. Now if we have a look at these relays, we have 3 relays on this line. We have 2 relays that are 16 amp. They will be for controlling the grill element and also the fan oven element. We've got a third relay here, which is 5 amp. Well, our base element is only 1200, 1300 watts, so that relay is perfectly capable of running that. Then we have 4 other relays along here, and these would be controlling things like the fan motor, the cooling fan, and lights and so on, and switches. So all these relays are replaceable. They're not expensive and they're only soldered on. Normally they're 4 or 5 pin. I would have to desolder it to actually work it out. But I think they're 5 pin actual relays, and they only cost £5 to £10 to buy individually. What actually gets me with all this is this circuit board is nothing complicated. But yet the manufacturers charge £150 for something that actually costs them less money to produce than the old thermostat and the selector switch. Circuit boards are very cheap to build. On the back here we have the main memory chip, and we also have some other small components. But normally if your cooker is not functioning correctly, it's either something that's caused a direct short and blown the circuit board, or it's one of these relays that have become faulty. And it's well worth understanding which relay operates which component. Now, as I do not have the schematics from the manufacturer, I can't be specific on which relay does what, but I can tell you that the two 16 amp relays will definitely be controlling the grill element and the fan oven element, and the lower ampage relay will be controlling the base element. And these actual relays will be controlling 2 different fan motors, the actual light system on one relay, and I'm actually not sure on the other relay what it would be controlling. That would be very interesting to find out, but without having the schematics, I'm unable to tell you exactly. But anyway, there you go. These relays, as I said, if you do have a cooker that's not sending power to an individual element, these relays are common things to go wrong, and it's worth having a go at replacing them. All you will have to do is unsolder the 5 points, remove the relay, and then get the replacement relay to the value of what is actually printed on the original relay. I've actually already replaced the oven element in this and reassembled the cooker for you, and I have made another video for you on showing you how to replace the element. I had made a previous video on Hotpoint elements, but that was 16 years ago, and if you want to giggle, it's well worth watching that. It will be in the description below with the new video as well. I actually had hair in those days. The old element was split, as you can see here, and you can see the distortion in the actual shape. The element had blown and gone open circuit, and it might have even tripped the electricity supply. But what I really wanted to show you here was the differences in the wattage and what actually happens, so you understand what to look for when trying to diagnose problems with your cooker. Now at the moment the oven's already been on, being tested for the last 15-20 minutes, so it's hot, and the cooling fan is running, which is pulling 13 watts. But that shouldn't affect our test. We turn this on now to fan oven element, and we set it to 180 degrees, manual setting. You will hear the 2 relays click, one for the fan motor, one for the fan oven element, and on the meter there now you can actually see that the appliance is drawing 2250 watts of power. That's 40 watts for the bulb, approximately 20 watts for the fan motor. The cooling fan is running as well, plus we've got 2 kilowatt for the fan oven element. And there you go, nice and simple, easy diagnostic when you know how. These smart meters are really valuable at diagnosing problems with your cooker. Now we're going to be giving this cooker away in the next couple of weeks to a family in need, and we're going to be doing a short video for a competition on this, which you can actually keep an eye out for on the main channel. I'll put the description details for that in the description below. But if you need any parts for your cooker, remember, use your full model number off the identification plate. It is very important to use the full model number, and on some occasions to use the PNC number as well. Thanks very much indeed for watching this video, and if we really helped you, you can always click on the donate button, buy Paul a beer, and that will support the website. Thanks very much indeed for watching this video.